Hello guys, welcome to my YouTube channel. In this video, I will just talk about the general architecture of the neural network and some notations that we follow while working with neural networks and understanding the computations, how it does. Okay, so let's get started. So this is how a general neural network looks like. So it has some layers in it. So first will be input layer, the last will be output layer, and in between input and output layer, we call them as hidden layer. So there can be one hidden layer or more than one hidden layer. It depends upon the architecture that we decide upon. Okay. Now, whatever circles you are seeing here, right? These are called as neurons. Okay, neurons. These are all the units, or you can also call them as nodes. Right. So these are all different names for this particular units. So it applies the same naming convention applies for the input layer, hidden layer, and output layer also. So everywhere these circles are called as neurons or nodes are units, right? And this is a two-layer neural network. In our example, what we have taken in a general neural network architecture, this will be called as a two-layer neural network because we do not count input layer as one of the layers with the neural network. So this will be 0th layer. This will be first layer, and this will be output layer or second layer. Okay, where we have the predictions. Right now, the number of neurons in each layer decides the size of that particular layer. Okay, so coming to size of a layer, it is nothing but the number of neurons in that particular layer. In this layer, for the first input layer, the size is 3 because we have 3 neurons in it. Okay, so that's done. What will be the size of this particular hidden layer or size of the first layer? It will be 4 because we have 4 neurons in it. Correct? And the output layer or the second layer is of size 1 because we have only one neuron or one node or one unit in it. Right? This neural network will have some parameters to learn. Right? And we call that parameters as weights. So in machine learning, we represent it as theta and call them as parameters. But in neural network, we represent it as W and call them as weights. Okay. So this is just the change in the naming conventions. That's it. Nothing much. Okay. So now these weights, the size of these weights or the number of weights associated with each layer will depend upon the size of the layers that we have in each layer. Okay. Now, since this is a two-layered neural network, it will have two set of weights associated with it and two biases. Okay. Now, this part, transition from input to the hidden layer will be governed by some set of weights called as W1. And transition from hidden layer to output layer will be governed by some set of weights W2. So this 1, 2 enclosed in the square brackets above W will represent the layer number. So in general, you can say WL. Okay. Now we will see what will be the size of W1 and W2. So the size of W1 will be equal to size of first layer, right? Size of first layer and size of input layer. So this will be a matrix of shape 4 by 3 in our case. Because in our case we have 4 neurons in our first layer and 3 neurons in our input layer. So the size of this weight W1 matrix will be 4 by 3. Okay. Similarly, the size or shape of the weight matrix for layer 2, it will be 1 by 4. Right. And there is a general rule for that. It will be S2 cross S1. So let's say we are computing the shape for layer 2 weights. Okay. So what we can do, weight 2 is equal to size of layer 2 multiplied cross size of layer 1. So in general, In general, we can say weight of layer L will be is equal to size of that layer cross size of previous layer. Okay, so this will be the size of the matrix, and each layer will have bias associated with it. So B of 1 here and B of 2 here. Okay, and it will be only single number. It will not have multiple dimensions. It will be a single number, 1 instead of n, it's 1 here. So weight 1 is a matrix of shape 4 cross 3. Weight 2 is a matrix of shape 1 cross 4. Okay. So how it will look? It will look something like this. Weight at the first layer, which is of shape 4 cross 3, we represent it in this kind of matrix. And weight at second layer is 1 cross 4 matrix, and we represent it in this way. 1 cross 4 here is 1 row 4 columns. Here it's 4 rows 3 columns. Okay. So this is about general architecture, and these weights are learnable weights. Just like in machine learning, we had thetas where we update them using gradient descent. Same way in neural networks, we will update these weights with the help of gradient descent, and also there is something called as backpropagation, which I will talk in my upcoming videos. Okay. So this is the general architecture of neural network. Now we will understand, or we will stick to some kind of notations and representations, so it will be easy to understand how neural networks compute, what all computations happen in case of neural networks. To understand that, let's stick to some kind of notations and representations. Okay, so as usual, M will represent the number of training examples that we have, how many training records that we have, it will be denoted by M. N will be number of features for each training sample. Okay, so and L will be the layer number. In this case of neural network, we will represent L for layer number. Okay, capital X will be a notation used to represent the collection of entire training data with us. So how it will be? It will be something like this. So x of small x of 1 will be called as first training example. Small x of 2 will be second training example. Small x of m will be mth training example. Now this x, each training example will have n number of features. Correct? And how we can represent each features? It's in this way. x1 of 1 will be first feature of first training example. x1 of 2 will be second feature of first training example. x1 of n will be nth feature for first training example. So each training example will be of shape n cross 1. It will be a matrix of shape n cross 1. Okay. Now what we will do, we will stack these together horizontally and call this as our capital X. Okay, this is our data matrix, and it will be of size n cross m, right? N cross m. Hope this is clear. Where x1 is this, x2 will be x2 of 1, x2 of 2, x2 of 3, x2 of n, and similarly the mth training example will be denoted as x of m. Okay, so please get acquainted with these notations and representations, and get acquainted with the weights, the size of weights, in other words, the shape of the matrix for each of these weights, and what bias is. So bias is just a number at each layer, it will be different. Okay, so that's it for this video. Next video is on neural networks computation. It's going to be a long video, but before seeing that, you need to make sure that you understand these nomenclatures and the general architecture with this particular example, where we have two layers, one hidden, one output, and one input. Okay, so thanks guys. If you have not subscribed to my channel, please do subscribe. I'll be releasing so many quality contents upcoming in the upcoming duration, so please stay tuned. Till we see in the next video, happy learning. Bye bye.